This is Bob Petta from the College of the Fleas, and this lesson is on solving systems of equations by substitution. I'm going to start with 2x plus 3y equals -1, and y equals 2x minus 3. Graph these two and then find the point of intersection from the graph. But I'm going to use a different technique. I'm going to take this value for y and substitute it into the first equation. It's going to go in for that y. So I'll get 2x plus 3 times y, which is 2x minus 3, equals -1. Let's distribute. So I have 2x plus 3 times 2x is 6x. 3 times -3 is -9. Now adding these things together, 2x plus 6x is 8x, plus -9 is -1. Add 9 to both sides, add 9 to this side, add 9 to this side, and I get 8x is 9 minus 1, 8x is 8, dividing by 8, and we get x equals 1. And what's nice about the way that I have this page laid out, now I can plug that x equals 1 in over on the other side. So I have y equals 2x minus 1, but x equals 1, so y equals 2 times 1 minus 1. Minus 3, excuse me. Y equals 2 minus 3. 2 plus -3, and we get y equals -1. Now we should check. So I have two equations. My point is x is 1, y is -1. Let's check it in the first equation. Does 2x plus 3y equal -1? 2 times 1 plus 3 times -1, does that equal -1? Does 2 minus 3 equal -1? It does. We'll call that a check. And then in my second equation, I have y equals 2x minus 3. Y equals 2x minus 3 does it. Y is -1. Does -1 equal 2 times 1 minus 3? Does -1 equal 2 minus 3? I think it does, so that's also a check. So that tells us that we've done this correctly. We've gone ahead and we found our solution. Now, what was nice about this problem was that y was already solved for. My first equation was 2x plus 3y is -1. My second equation was y equals 2x minus 3. Since y was already solved for, I was able to plug it right in. But it's not usually quite that simple. Let's look at another example. How about x minus 2y is 7. And 2x plus 3y is -21. Now, to use the substitution method, I need to solve for one of the variables. I could solve for this y, it's got a 3 next to it. This x has a 2 next to it. This y has a -2 next to it, or this x, which has a 1 next to it. This x is the easiest one to solve for. So I'm going to solve for x in the first equation. How? Add 2y to both sides. So we get x equals 7 plus 2y, or x equals 2y plus 7. Now, where is that going to get shoved? In for x in the other equation. So where I had x, replace 2y plus 7 in parentheses. 2 times x, what is x? X is 2y plus 7. 2 times 2y plus 7 plus 3y equals -21. Now our goal is to solve for y on this side. 2 times 2y is 4y, plus 2 times 7 is 14, plus 3 times y equals -21. Let's combine like terms on the left side. 4y plus 3y is 7y, plus 14 is -21. Let's add -14 to both sides. And what do I get? That goes away. We get 7y is negative 35, and then divide both sides by 7, and we get y is negative 5. And then we're going to go ahead and substitute that y into this equation. So this y equals negative 5 comes up here and goes in for that y. So I have x equals 2 times y plus 7. So x equals 2 times the y value is negative 5 plus 7. So I get x equals negative 10 plus 7, and I get x equals negative 3. So we have x equals negative 3, we have y equals negative 5. We want to do our check. X equals negative 3, y equals negative 5. So we'll plug that in and see if that's what we get. So our first equation was x minus 2y equals 7. We want to see, does it equal 7? X is negative 3 minus 2 times y minus 2 times negative 5. Does that equal 7? That's negative 3. Make that plus negative 2 times negative 5 plus 10. Does that equal 7? That, of course, is yes. And then the other equation is 2x plus 3y. Does that equal negative 21? Does 2x plus 3y equal negative 21? 2 times x, 2 times negative 3, plus 3 times negative 5. Does that equal negative 21? Does negative 6 plus negative 15 equal negative 21? That's also a yes. So that checks. So you see the process that's involved. You solve for one variable, then plug it into the other equation, and see if you can find your solution. So let's do a few more of these if we can. How about the following? How about x plus 2y equals negative 3. And 4x plus 5y equals negative 6. We want to find the easiest variable to solve for, and that would be this x, because that has a 1 next to it. 5y, 4x, 2y. If I solve for any of those, that's going to require me to go to fractions. So if I solve for this x, we're going to subtract 2y from both sides. Subtract 2y. Subtract 2y. What do we get? X equals negative 3 minus 2y, or negative 2y minus 3. And now that is going to go in parentheses into the other equation. In parentheses here. So 4 times parentheses, negative 2y minus 3 plus 5y equals negative 6. Change the minus 3 to plus negative. Distribute 4 times negative 2y. Negative 8y plus 4 times negative 3. Negative 12 plus 5y equals negative 6. Like terms, negative 8y plus 5y, negative 3y plus negative 12 equals negative 6. Let's add 12 to both sides. Add 12, add 12. This goes away, and I get negative 3y is 12 minus 6 is 6. Let's divide this by negative 3, and I get y equals negative 2. Now, where does that get plugged in? That gets plugged into the other equation. We're going to take this y equals negative 2 and move it in for that y. So now I get x equals negative 2 times y, so that'll be negative 2 times negative 2 minus 3. And I get x equals 4 minus 3. X equals 1. So we believe the answer is x equals 1, y equals negative 2, which is the point, 1 comma negative 2. We like to write the solution set like this once in a while. And then we're going to check that in both of our original equations. Our original equation, x plus 2y is negative 3, and 4x plus 5y is negative 6. So to do our check, x plus 2y is negative 3. X is 1 plus 2y, 2 times negative 2. Does that equal negative 3? Does 1 plus negative 4 equal negative 3? It does. And then the second equation I have is 4x plus 5y is negative 6. What is that going to be? 4x, 4 times 1, plus 5y plus 5 times negative 2. Does that equal negative 6? Does 4 plus negative 10, does that equal negative 6? 4 plus negative 10 equals negative 6. It does. So I'm confident that my answer is right. All right, let's take a look at one more problem here. Let's look at 3x plus y equals 9 and 6x plus 2y equals negative 1. We want to solve for the easiest variable. 2, 6, 1 is the coefficient here, 3 is the coefficient here. This y is the easiest variable to solve for. So I'll solve for this y by subtracting 3x from both sides. Subtract 3x here. Subtract 3x here, or add negative 3x if you prefer. And I get y is 9 minus 3x. I'm going to write it as y equals negative 3x plus 9. Now that is going to go in parentheses and get shoved into the other equation. We're going to go ahead and substitute that y equals negative 3x plus 9 into the other equation here, so that I get 6x plus 2 times negative 3x plus 9 equals negative 1. Doing our distribution, 2x plus 2 times negative 3x, negative 6x plus 2 times 9, 18 equals negative 1. Adding up our like terms on the left side, we have 6x plus negative 6x, that's 0, plus 18, and I get 18 equals negative 1. So what does this tell us? 18 equals negative 1 is a ridiculous statement. What that tells us is there is no solution. Now remember, both of these things are lines. We have the line 3x plus y equals 9 and 6x plus 2y equals negative 1. What we have in essence here are two parallel lines. So one of them coming like this and one of them coming something like that. If you have two parallel lines, you are going to have what we call an inconsistent system. And in an inconsistent system, you have no solution. Sometimes we use this empty set notation to talk about a no solution case. All right, let's take a look at one last question here that is going to have some fractions, just to show you that it can be done, although it is not our favorite sort of strategy. So if I am working with the following question, if I am working with 2x minus 5y equals negative 4, and I am working with 8x minus 9y is 6, none of the variables are easy to solve for, but 2x has the smallest coefficient, so I'll solve for that x. Adding 5y to both sides, I get 2x equals 5y minus 4, 5y plus negative 4. Then I have to divide by 2 to solve for x. So I get x is 5/2 of y plus negative 4 divided by 2 is negative 2. And that will get shoved in for x in the other equation. So we get 8 times x, 8 times 5/2 y plus negative 2. minus 9y, which I'll write as plus negative 9y, equals 6. 8 over 2 is 4, times 5 is 20y, or 8 times 5 is 40, divided by 2 is 20 times y. 8 times negative 2 is negative 16, plus negative 9y equals 6. 20y minus 9y would be 11y, plus negative 16 is 6. We'll add 16 to both sides. And we get 11y is 22. Divide by 11, and we get y is 2. And then that gets shoved into the first equation for y. X is 5/2 y plus negative 2. So x is 5/2. The y value now is 2, or 2 over 1 if you prefer, plus negative 2. And we get x is 10 over 2, 5, plus negative 2, we get x is 3. I'm going to do a quick calculator check on this one. X is 3 and y is 2. The way the calculator check will work, find a spot with no shadow. I will say 3 store in x. Hopefully you can see that. I will say 2 store in alpha y. And then check 2x minus 5y. We hope it's negative 4, and it is. 8x minus 9 alpha y, we hope it's 6, and it is. So we are certain that our answer to that system of equations is the ordered pair 3, 2. And I will go ahead and write it in the curly braces. And that will conclude this lesson.